Welcome to Turn Right Machine Works. My name is Keith, and today we have an outside project, but we are going to be going in and we're going to be playing with our PlasmaCAM today to help us with our project. Well, this project started out with first off having a car worthwhile of putting under the protection, and this is what I picked out for protection for my my car. The Shelter Logic has been an excellent product, and I'm not here promoting that other than you know, I have no complaints. They've really done the job. I have a 14 by 40. You see the inside of that. I have the Inco cutoff saw, and I do a lot of cutting, and it keeps me out of the weather, and it's doing great. It's over 10 years old, and I haven't had a problem with it. So anyway, we're out here, and we're going to get ready to anchor this thing down so it doesn't blow around. And of course, these are the little helical anchors that they give you with this kit. Like the man says, he says, I got some helical anchors. You know, that's not a helical anchor. That's a helical anchor. Over the years, I have had a couple of these shelters, and I also have been through a couple near hurricane force. I think we even had one hurricane force snowstorm. So you get snow drifts, and you get a lot of heavy wind, and there's a lot of force. And these things will stay put if you do the right thing. Now, I need to put these into the ground, and my normal way of putting these into the ground is a heel bar and twisting these things in here. And I've done that many times, and you know, you only put in a couple of, well, you say a couple of them, but by the time we put in 8 anchors, that's what we're going to do. Those big long ones are pretty well winded. This ground right here is my driveway, and it has clamshells, and also this is an area where I had 3/4 stone drop for a septic system, and this is pretty thick and pretty stony for the first 6 inches of material, and then after that we got sand here, and that's what the helical anchors are going to be going into once we break through that surface. Now, my shoulder's blowing out, and it's healing. It's doing really good, and I have no complaints, and I don't want to have any complaints. So I'm looking for the easy way out here, and I want to build a socket that goes on the end of this. And the first thing that I can think of that I'm going to drive it in is one of my other favorite tools, is a pneumatic. Now, pneumatics work sometimes they don't work, and we're going to be testing this out because I need to put the theory to test, and it's worthwhile. I'm going to take an old 9/16 Husky socket, which gives me that 1/2 inch drive, and I'm going to go into the PlasmaCAM, and I'm going to build a socket. I'm going to be building 2 of them actually, but I'm going to first build the one for the big one here, and so that I have that 1/2 inch drive coming in, and I have a socket that will just slip over the end. So I slip it right over the end into the ground. That's the plan. All right, let's go inside and do a little fabrication. Okay, we're in here, and I got a pair of dial calipers, and I got a pocket scale here, and I have the socket we're going to use to drive it, and I have the large helical anchor, and I'm going to start drawing this out. On the plasma cutter, I have a piece of 1/2 inch thick steel, which will be the thickness of this, and we'll space that out when we weld it so it will slip over the 1/2 inch. And I have a piece of 1/4 inch material, which will be 2 outside pieces, so that we're going to make a cup or a slip over sleeve that's going to hold this, and then we'll mount the socket to the top of it, and then we'll weld the 4 pieces together to create the driver for our auger. So first off, I'm going to start out, and we're just a little we're about a 32nd under 2 inches, and I checked all of the units, and they're all conforming just about that same diameter. So we're going to just call that, we're going to give ourselves just a little bit room for air and everything else, and we'll consider that 2 1/16. Okay, so now I'm going to go ahead and turn on my screen. All right, let me move this coffee cup out of the way. Okay, I think we're all set. We're all set here. Get this. Okay, All right, first off, we're going to start out with a circle. So we click on our circle here, and we go ahead and type in 2 inches and a 32nd as far as diameter, and we're going to go ahead and put that down on the screen. I'm going to go ahead and go in here in my settings, and I'm going to just come out to design, and I'm going to unclick show closed paths, so that this will just give me the lines for right now. We'll show the closed paths when we get a little bit closer to finished product here, because it does swap back and forth, and it looks confusing sometimes while you're going. All right, I want a node to center that, and I just push center, and it creates the node in there. I'm going to marry those two together, or create a match, so that when I highlight one or the other of those two items, the node or the circle, I actually have them together. All right, that gives us our diameter. Now the depth of our socket, the depth, how much we want to come down over that socket, and we can just, I'd say 2.5 inches is probably good. So let's create a square that matches that circle, and first point is always 0, 0. And then we'll go ahead with the width. Is going to be 1/32, 2 inches and 1/32, I should say, by 2.5 on the length. All right. Now we come out here. That's where our square is, and we're going to just bring this up close to our other item. We're going to put a node in the center of the box, and then we can marry those two as well, and then we can line up that with this project here by lining up the nodes. And you can just zoom in and line those up. If you had an X and Y coordinate, you could also put that in there, but this is just quick to go ahead and zoom in, couple clicks, and you're going to be ever so close right there. I mean, we're making an auger, okay? Now you can see that the center of the box is not really giving me the total depth of that. I need to bring that clearance on down there. So I'm going to go ahead and move that down. And I'm going to bring it down here, but I'm just going to go ahead and side it side to side until I know I'm matching up with the lines. There we go. All right, and then we just kind of zoom in and we make sure that's lining up there. That's lining up there. All right, now to double test that there, let's go ahead and trim off this. Okay, trim off that. Trim off that. We can marry those together. Now we have one closed loop there. We have one green spot that's left up here. We can get rid of that. That's a closed path. When you got your purple and it turns green when you highlight it, that is a closed path. And that's what we want for right now. Now we need, that's our inside there. This is going to be open at the end, but we have it boxed off right now just so we know we have security on our radiuses around here. All right, now we need to go ahead and duplicate this basically in a larger piece altogether. So we can copy this, put it over here, and we can go size on that, and then we can size this whatever size we want. Then move that over this. We can also move this down. We keep the wall thickness pretty close to the same up here at the top and side to side. We can even bring it down a little bit more if we wanted to. Alright, that's pretty uniform. But let's go ahead and let's give it just a little bit more at the top here, because we're going to be cutting out of it to put that socket in there. And I kind of like that right there. Now our 1/4 inch plate that's going to sandwich around the side is going to be somewhere between that inside dimension and somewhere around that outside dimension, so I can just go ahead and copy another one of these, and then I can size that down somewhere in there, move that over here, and I can also size it up while I'm in here, so that I know that I'm basically just going to have a nice weld bead along here, and it's going to hold it pretty good. I kind of like that. Alright, let's go ahead and draw a line. You can punch in the coordinates of a line, or you can actually draw it, hold it until it is straight, unbroken, and it actually creates a solid line level. Alright, I had a little interruption there, but I come right back. Alright, the line that we went ahead and created will give us a break line that we'll be able to move across all of our pieces right here, so that we can create an open bottom, is basically what we're doing. So we laid that over, and you can see I'm slightly above that line, so I know that I'm crossing all over here. And I'm just keeping this simple so that we've got our pieces. All of our pieces are right here now, with the exception of not fitting our socket in here at the top. So let's go ahead and let's take and measure our socket. And we're basically about 800 on the width, and we want to go ahead and three-quarter inch deep and 850 on the width should give us enough. So let's create another box. 0, 0, enter that, and this just there's a pinpoint at the corner, and that's how your box is all. So it gave us that center point no matter where it is. Now I'm just going to type in the rest, and we're going to go 3/4 on the width, and what did we say? We said 3/4 on the width, 850. 850 on the width and 3/4 on the height. Type it in right. Alright, there's our square now. Now we can go ahead and we can move this up to the top of our center here. And if we go like this and we put a node in the center of that, there we go, and we marry that together, then we can go ahead and we can draw one last line here vertically. There we go, and we move that on over here. Now we wanted to line that up basically with our center, and I'm just grabbing one of those nodes and I'm going to bring it over here, eyeball it to where I know it's close enough. For the tolerances that we need for a welded impact socket, you know, we're doing great. Alright, let's move this down here now, and I want to line that up in here. I'm going to leave this protruding outside this corner here. It makes it easy to go ahead and trim lines. Alright, now we've located where our socket is going to stick down into the top of our holder here. Now let's go ahead. I'm going to zoom in on this whole picture here, and I'm just going to grab my scissors up here, because this lets me trim off what I don't want. First off, this vertical line, it serves no purpose of trimming, so I'm going to delete that. And now I can grab my scissors, and we'll start right down here at the bottom. Okay, we're not going to need that line, We're not going to need that one. We're not going to need that one. All of it's open here. That's open. That's open. We're not going to need that one. That one. That one. That one, that one. All of those. Alright. Before I cut anything else loose, I'm going to go ahead and grab those and delete those. Delete that. Okay. I want to pair this, copy this before I delete anything else, because we're going to have two drawings used out of the same thing here. One is going to be our outside shell, the 1/2 inch thick, so we will go ahead and finish cutting out. Actually, we can just delete that line, delete that line. And that's our 1/2 inch piece. Now we need the 1/4 inch pieces, which are going to be deleting the outside, and that's what we're going to do. We're going to go ahead and delete that, delete that, trim that, trim that, trim that, and the last one there. Now we're going to marry. I have one piece of this whole thing highlighted, so I can hit marry. There's that part, and I can highlight this one here, marry there. There's our two parts. This is going to be 1/2 inch. This is going to be 1/4 inch. All right. So let's get our materials set up. Now we need to create cut paths, and that's as simple as coming up here and going convert to cut path, and depending on where we want to go ahead and start, I would say I'm just going to start down here on both of these here. I'm going to marry that so that the cut line and the part itself, they stay together, both of those. Now when I grab it and I move it, it moves together. Let's go to the table, and we're going to start playing with setting up our material there. Then we'll come back and we'll set our cut path in relationship to the table here, and then we'll get cutting. Alright, I got a piece of 1/2 inch up here, and I got a piece of ply. I put the plywood, and I use these old curtain pieces that I actually trimmed off of a curtain after I used it to blanket apart for me. And all I do is I use those to control the draft, so that it kind of focuses the draft of where the cut is. And most of the time I can just run my lower blower and not add the noisy one on the starboard side here. Alright, we're going to go ahead and we're going to cut out our piece, and I think I might go ahead and might just put it on over here into this corner here. We do need to add a ground. We're grounded through the table, but sometimes through dross and roughness and just little pinpoints, you don't get a really good contact. So I always like to add an extra ground, and this ground is an extra ground. It actually it's added at and where the ground comes and mounts to the grill, like you're supposed to when you assemble a PlasmaCAM. And this is an accessory, and it lays into the trough, and I keep it out of the way so it doesn't drape over any of the areas that the PlasmaCAM travels or would crash into. Okay, now you want to know how I go ahead and, you know, I put a piece of material on the table, and I can bring the cutout and put it in place of this, or I can put the cutout on the table if it has to, and then I can move the material around on the table to cut it out. But what I normally do is just go ahead and I come on down to where my material is, and I kind of like, I'm going to mark this lower corner down here. Roughly, give yourself an extra 1/8 of an inch of material so you know you're inside. All right, now we're on the screen here, and we bring this part. We just we can click move, and then we can actually bring that part right on down here, and we can set that in that location, and we know that we're going to go ahead and pierce and come in and cut that material. Now it's a little bit close to this outside edge, and it's going to cut clockwise around this part, Then I come down here, it's going to be cutting down a really skinny part here. And I want a little bit of strength on the outside. I don't want it to be so close to the edge. So I'm just going to give myself a little bit more over here. Like that. Alright, now we need to go ahead and go in our settings. We'll go into settings and we got to set the thickness of material. I've been cutting out those plant hangers and they're all 100 thousandths, so we need to step up here about 500 thousandths, and we want to go ahead and set auto shift, zero shift and auto arc voltage, so it controls the height control and all of that. And I know on 1/2 inch, I know the cutting is probably down around 20 inches per minute, does a pretty clean cut, I believe. And let's just go back. I want to make sure, because I actually carry a little bit lower height on the thinner gauge, and I want to go ahead and raise it up a bit. I kind of like about that. Let's give that a shot there. Alright, so a lot of it's by memory. I mean, you can jot notes for everything that you've ever cut, and sometimes, depending on if you have a new consumable in there or an old consumable, it makes a difference. Or if it's dirty on the surface, clean on the surface, there's a lot of variables, but we're going to give that a shot there. Alright, so let's get some power here. And our airflow's on. Now, also too, you can go ahead and, I'm just shutting off my auto cutting, and I'm going to click start. And this start will go ahead and run it through. That's where the pierce will be. And it's going to run it through its whole program. Now I can speed this up if I wanted to, and I already know kind of where it started, and we're basically going to be all free, and where it started we're going to be coming down there, so I don't have to run through the whole test. I'm happy with that. So we can just close out that. Alright, now I'm just going to come in here because we can focus closer on centering that part there, and the part cut on the screen will follow the cut as we're going. I turn back on the auto. We give a little ventilation on the one side there. Alright, I think that should be adequate for your viewing. There we go. Now I'm staring down in there, and that 20 inches a minute really does leave me a good finish. That's a little socket area. Excellent. Okay, bring it up. Move it back out of the way here. Alright, I'm just going to reach in here with a magnet, I think. There we go. Okay. Okay, that's it. That's going to be a nice fit right there. We did good. Alright, here's the socket. That looks dynamite. Alright, let's see what we got. Not too much dross on the back. How does that chip off? Does that chip off pretty good? Oh yeah. Okay, I like that. Now let's go ahead and I'm going to put a piece of 1/4 inch up here, and we're going to cut the other 2 in pieces, and we're going to get this welded. I'm really anxious to get out there and give this a try in the ground. Alright, we're getting ready to cut out our 2 1/4 inch pieces. We got the material up on the machine. We got the ground on. Alright, this is our drawing. We moved it down. There's where our cutter is in relationship to the table. Now we want 2 of these, so we just go ahead and we hit copy, and we just go ahead and put a second one over here, and then we highlight both of those, and then when we hit cut, we can cut that. Now before we do that, we have to go back into settings, go into height control, and we're going to take and we're going to knock this down to 1/4 inch. We're going to go ahead and reset our 0 and 0 there. We're going to keep that same height there, and our cut speed, we can increase this now, and I'm just going to go ahead and I'm just going to hit 40 in here. It's a good, comfortable, good, clean, and that's what I'm looking for. The best edge is what I'm looking at. I'm not looking at cutting out the fastest parts. It's just the best edge. And 40 on 1/4 is good, 20 on half is good in general. If I was going to be doing production, I would want to tweak that out to where I am creating a more profitable or less costly time and speed. Alright, we're set, we're good to go. Let's cut it. Okay, hang on, I gotta get that. Alright, did you see the mistake? Okay, I'm not cutting out mini horseshoes. I'm supposed to be cutting out houses with no door. Alright, let's get these cut out here. Whoop. Let's go ahead and move these where they need to be, and here we go. That looks a little better. That should hold the socket together. Okay, we got our sander here. I'm gonna move our coffee over there. All right, and we're just gonna hit this edges here where we're gonna be welding. All right, they'll be able to stack up here, and let's just see. We're gonna put these in here. I just want, just for kicks. We're not trying to line them up or whatever. We just want a thickness thing here. Okay, is this gonna slide in there? It's tight. Okay. We actually may want to give it a few thousandths on the thickness, so I think we're going to go get a couple pieces of strapping material or something that we can get that, because we want that to go all the way down in there like that, so it's buried right in there. All right, so just a little something to hold it apart, and our socket is going to be able to fit right there in the middle, be welded all the way around. All right, let me get something to space that, and then we'll get started. We're just going to use our wire feeder, our little Miller-matic 250. All right, this is just aluminum flashing. If you're curious, it's 10 thousandths on the thickness. So we're actually putting 20 thousandths because we're gonna put one on this side here, and actually we're gonna go ahead and we're gonna stand these up like this and like this. Just like that. Just so I can give it a couple light tacks. I'm not squeezing it real hard because I want to be able to pull those out of there. Alright, I got my ground down here on the table, but it works better if you have it on the item you're actually welding. Alright, and purge the gas. We haven't done that. And there, and I might be close. Wire speeds, yeah, that should be close. I had it set down, but I know I want a little bit more penetration than I had. All right, pretty good. Alright, we're going to loosen this up a little bit. That's pretty good, huh? Okay, now we're going to break it apart. It's loose on one side there, but it's grabbing on the other side there. Okay. I'm going to go get my chisel just to spread that out just a little bit. Don't go anywhere. Easy removal, right? You know how hard I'm trying not to have to break this apart? Okay. I fought it. It is still all together. I was able to get it out of there. It wasn't easy. But I'm gonna add a second suggestion, okay? And I'm still going in with the aluminum shim, but I'm not putting it between those parts. Again, okay? I just want to make sure that we have enough room on outside, and I know I can pull this thing out. And then that aluminum shim won't be stuck in between everything there. And I'm going ahead and closing this up where it was, then relaxing it slightly so I'm back in shape. Now I'm going to go for my other 4 tacks. All right. All right, now we just tap this off of here, and we can pull that out of there. Check the fit. Nice. There's a little tiny burr right on a BB there on the end of there, but that's good. I'm happy with that. Okay, let's go ahead and I'm going to set this down here. Now our socket is going to be sitting in here. We kind of want that. We want that to be kind of straight in line as much as possible instead of going like this. So I'm going to go ahead and put this in here. This is where our ground is, and we're looking pretty level there. And actually, I like holding it up to that wall on that side. Seems to be more true. And if I hold it like that, I put a tack over here. Having a hard time with my mic fitting in this helmet here. See if I can adjust that. Okay. I'm just going to put it on the helmet. Okay. Got it down here. Right there. Looks pretty straight. I'm just looking for a little leverage here. There we go. Just pull it down. Okay. Put on a fan here, get a little ventilation. Don't need to be breathing extra smoke here. Okay, that socket is joined to those 3 pieces pretty good there. We're going to go ahead and I don't think it needs that much strength, so I'm just going to do a down hand on all 4 of these here, and this is sticking out pretty easy over here, so I'm going to hit these 2 here and then go over and hit those 2. Okay. Now I think that's good. I'm not going to put, I don't believe more weld is better. And I'm pretty happy with that piece right there. I'll get a couple pictures of it. We'll get it cooled off. Almost looks like a flask, huh? Alright. Alright. This is our test zone because I don't have my big airline to reach all the way where I need to reach it. So I'm just going to test this right here. But yeah, I got to move, got to lay out my lines, and I'm going to be playing with that, and I'm going to do that off camera. But I want to prove or disapprove, disprove whether we're going to be able to drive these in with a pneumatic and our little socket driver. And first off, and we did lube this up. Okay, you just want to make sure that that's not going to spray all over your stuff there. Sometimes putting a little bit much in there. After all that welding, that still fits on there. I think I'm going to try to have something on there. I think if I blow that around right now, I'd be flying around, and of course we have areas we don't want to fly into. Okay, I don't know if that's going to be an issue. It may. Okay, that is putting that down into the ground. I am making forward motion. You see a couple times it actually stopped because we do have rock. We have clamshells. Some of the clamshells, they were dumped whole here, so actually I have some whole clams. But I am making motion, and actually this is a little easier than spinning it around by hand. So even if it takes me a little while to put them down in there, I'm going to continue running this down a little bit here because I want to see if maybe if I hit the sand or whatever, it might be a little softer. Like I said, this is my driveway. This has been years of compact in this area right here. This has never been dug up. I've had plenty of other areas in the yard dug up, and I know they're soft. I sink these helical anchors over there in the middle of the yard. They are straight sand, no hard pack at all. But I would rather have a helical anchor go in and be firm like this to hold down something that I don't want to blow away in the storm. So I'm going to play around with this a little bit more. Alright, evidently I've got down past some hard pack here because it's pretty constant moving now. I'm in sand. I may have to go throw some more lube in here or check my air pressure. I might be low on air pressure here. All right, we checked the air pressure. We gave it a little bit more lube. Okay, our test shows us that we can get one down in there. I haven't checked my actual settings on this thing either. Okay, now, will it come out of the ground? Because this ain't where we want one. I don't know. Am I more more tired than cranking one of those things in my hand? I don't know. There you have it. Simple question. Can you make a pneumatic socket fit your helical anchor and put it in where you want it? I think you can. Definitely didn't put the wear and tear on my shoulder. Alright, we went ahead and we got some boards spreading our span to hold this thing where we want to anchor it down, so that the canvas and everything else will be taut enough to the four corners. And we already put one helical anchor in, and we used our old 20-year-old import impact, which you saw the test outside, which led us to believe whether this was really doing the job or not. So what I did is I went ahead and borrowed a really nice, this is an Ingersoll Rand, and we're going to go ahead and see if this actually does the job a little bit better than that. I was wanting to blame it on 1/4-inch air hose for 100 feet and out here in the boondocks compared to the air compressor, and a couple other things there. Now, we've already put that anchor in. Once we put the anchor in, we use an exhaust clamp to clamp the frame to the anchor. And that's what makes a big difference. Don't be putting those cables and lets everything move around. You cannot let this thing start moving. It has to be anchored solid. You let the thing move around and it'll destroy itself. Alright, so I'm going to go ahead and I'm going to bring you in close so that we're going to put this next helical anchor in here, and we're going to see if this Ingersoll Rand makes a difference in how this helical goes into the ground. Okay, we're putting the helical anchor in on this flat right here behind the clamp before the curve. We want it to be in line there. Now we're spanned across here the right distance, and we'll be bringing that back in here. But for right now, I'm going to go ahead and I'm going to push this back out of our way a little bit, and I'm going to, that's where I got it marked. Go ahead and put that on there. Get everything out of the way here. Okay, that's where I want it. Get it in the right direction here. Okay, we're gonna go make sure that we didn't shut off our air compressor while we were out of town there this morning. I'll be right back. All right, believe it or not, I went in there and the air compressor's on, and there's actually 110 pounds of pressure in there, and so the conclusion is it's just a hard drive driving in a helical. This is putting it in a little bit faster than the import, but I'm not going to knock the import to the point where it's silly. All right, then we're going to pull this off of here, and we're going to go ahead and put our torque wrench on, which this is what we've been doing to drive them down in here when we get real close to it. Was my tools coming apart here? I put my palm on it and I undid that Allen wrench right in there, huh? we gotta go find out what's wrong with this. Well, that's pretty cool. I pulled that off, and there's a little roll pin in there, and it came out, and it had it holds a spring, and when you flip it one side to the other side, the spring rocks the ratchet. All right, so it's not broke, it just came loose, and I caught it in time. All right, now I can put my hand back on the top like I had, and that's what happened, is that screw wasn't tight enough, and feels like we're down in the sand now. If I had to weight or something on this, it'd probably go down a little faster with the helix. Something a little crunchy right there. I sprung into a root one time, and that could have been a root too. All right. We're going to have to get our hammer to tap that loose. I didn't sand the little BB off the side of the weld there on that one. All right, with our helical down here to the ground level, we kind of like it like that, because we're going to anchor that pipe with this loop, and what we do is we go ahead and have this loop going through here, and then this arch holding the pipe, and that grabs a hold of the pipe, keeps it from coming in and out. Of course, the anchor holds it from coming up, but we also are holding this thing in and out, and I've found that these muffler clamps really work great. So we just go ahead and we go like this, we bring this in, we're going to slide this whole thing in tight against we're tight against that now, and we'll just rotate that like that. The 2x4 is holding our span exactly perfect. They want 12 inches or 12 feet to the outside. So we got that going through like that. And then we got a muffler clamp like that. Of course, we were just dismantling the other section there. Okay, that's not going anywhere. All right, and to me, this is mounting in. And of course, we're going to take and we'll tap that board. We got some pressure treatment material coming in, and we'll go ahead and we'll span that in there. Now we can pull our boards out of here, and we're going to be putting a bar all the way through on the back wall. There's a bar there, and then we're going to hose clamp that to this bar here, and then that'll secure the back wall. All right, we got to run down to the store and get a couple more muffler clamps, and I had a couple other. I wanted to go ahead and get some pressure treated timbers or runners to run underneath the side feet before I put those helical anchors in. Now, sometimes you get ideas and they're pretty strong, and they could be impacted in your brain where it's got to work. Follow through. Follow through. It may not always be a failure. This didn't work quite as well as I thought it was going to work, but it did cut me some slack on my shoulder. All right, till next time, get her done.